Probability is one of the hardest things that students find difficult in VCE methods, but luckily I would say I'm a bit of a connoisseur when it comes to understanding probability. So let's get understanding and let's try and start with a fresh slate, I know a lot of people don't really like probability. It's a lot of words, it's a lot of interpretation from big paragraphs and whatnot, but let's try and break it down into, parts that we can really understand. So we're going to start off with a really basic example. It's one of the more basic examples that we have in probability, and it's because each of our outcomes are equal probability. So for example, we have rolling a dice here, right? A 6-sided dice. Now, there's 6 possible outcomes, and each of them have an equally likely probability. So each of these outcomes are going to have a 1/6 probability, and that's just because it's 1 for one outcome divided by 6 possible outcomes in total. So each of these are 1/6. Now, obviously, not all events that happen are equal probability. Some examples of things that are equal probability are rolling a dice and also flipping a coin. We know heads and tails are 1/2 each. But obviously, if you have the probability of, let's say, 2 teams playing a sports match and one team is more likely to beat the other, then that probability would obviously be higher, and you can't kind of just split it up equally like we've done here. So it just depends on the event that we're actually talking about and the situation that we're talking about. In this case, it's very easy, and it's kind of implied when you do roll a dice. So when you have anything like a fair event, so a fair event means equally likely outcomes, it's really easy to calculate the probabilities of them. It's just the outcome that you're talking about, or the number of outcomes you're talking about, divided by the total possible number of outcomes. And we have a few examples here to illustrate that fact, and obviously there's different combinations of them. For example, the probability of rolling a 5 is simply 1/6 because it's one possible outcome out of 6 possible outcomes. Probability of rolling an odd number, how many odd numbers are there? There's 1, there's 3, there's 5. So that's 3 outcomes out of 6 possible outcomes. So we have 3 on 6, which is equal to 1/2. Now, you might not recognize this from last year, or you might recognize it. The term for it is conditional probability. Now, conditional probability is that's one of the things that's recycled from year 11 that's kind of skimmed over in year 12. So we're just going to make sure that we understand it now. So how we read this is the probability of rolling a 5 given that the number that we roll is odd. So let's try and break that down. Probability of rolling a 5 given that the number that we roll is odd. So essentially what it's saying is we know that the number that's rolled is odd. What's the probability of that number being a 5? And when you think of it like that, and when you break it down like that, you might see that the sample space, or the total number of possible outcomes, has actually reduced. And that's because 2 is not an option, 4 is not an option, and 6 is not an option anymore. So how many options do we actually have? We have 1, 2, 3. Now, out of those 3 possible outcomes, 5 is obviously only one of them. So the probability of this happening is actually 1/3. Now, this is kind of the conceptual way of answering this question, but there's actually a formula to solve this question as well if you don't really want to do the conceptual way, but I just wanted to tell you guys as a conceptual way so you guys have an understanding of where the formula actually comes from. But before I go through the formula, I just want you to understand that whenever you have a conditional probability, it's always the first event given that the second event actually happens, okay? So when you know that the second event happens, what actually is occurring is you have a reduced sample space. Okay, I'm just going to write that down. Reduced sample space. Now, what exactly is a reduced sample space? It's what I did here, where I took out the 2, the 4, and the 6, because since my number is odd, that reduces them outside of the sample space. The original sample space was all 6 numbers. Now the sample space is only 1, 3, and 5. So when I say reduced sample space, it just means that because the number is odd, it reduces the total possible outcomes that we have in the situation. Now, the formula for this, if we wanted to apply it, is the probability of the intersection between the 2 outcomes that we're talking about here, divided by what's given, okay? So what's the probability of a number being 5 and odd? Obviously, that's just 1/6, because, you can see 5 is a subset of odd numbers, a subset meaning it's just contained inside the other set. So for example, the set of odd numbers is just 1, 3, and 5. The set of 5 is obviously just 5 by itself. So the probability of 5 and odd is the same as just talking about the probability of a number being 5. Now the probability of a number being odd, we already talked about before, is 1/2. So I'm doing 1/6 divided by 1/2. That's the same as 1/6 multiplied by 2 own 1, doing state change flip. And you can see 2/6 becomes 1/3. So I've got the same answer before, just thinking about it conceptually, but this is just the formulaic way of solving the same question.